The Boeing 777-200 airplane is approximately 209 feet from nose to tail, 60 feet 6 inches to the top of the vertical stabilizer. The minimum turning radius is 156 feet. Depending on configuration, the maximum zero fuel weight for the 777 is 190,500 to 195,000 kilograms. The maximum taxi weight is 230,400 to 287,800 kilograms. The maximum takeoff weight is 229,500 to 286,900 kilograms. The maximum landing weight is 201,800 to 208,700 kilograms, again depending on configuration. The 777 is powered by engines from Rolls-Royce. The engines are high bypass ratio. The engines produce 74,600 pounds of thrust. The engines are huge, with a fan diameter of 9 feet 2 inches. The 777 is designed for medium to long-range flights. The domestic regional market airplane can fly from 4,000 to 5,000 miles, and the international continental market airplane can fly from 6,000 to 7,000 miles. What this means is trips within these circles. The maximum cruise altitude is 43,100 feet, and the maximum operating speed is 0.87 Mach. The 777 flight control systems operate through a fly-by-wire system. Inputs from the pilot are sent to flight control computers, where electrical signals are sent to control the pitch, roll, and yaw. The flaps and leading-edge slats also operate electrically through the fly-by-wire system. In addition to the fly-by-wire system, mechanical control is provided for the stabilizer through the alternate pitch control system. Roll control is through the control wheel to a spoiler pair. There are 8 passenger entry doors, 4 on each side of the fuselage. There are 3 cargo doors, 1 forward, 1 aft, and 1 bulk. The forward cargo door permits loading of containers and pallet-size cargo. Special coatings on the pilot's windshields repel rain, alleviating the need for a rain repellent system. In addition to the usual pitot and TAT probes, an ice detector probe senses the buildup of ice and automatically activates the nacelle and wing anti-ice systems. A tail-mounted APU can provide the 777 with electric power both on the ground and in flight. The APU also supplies bleed air on the ground at up to 22,000 feet. The fuel system has 3 main tanks, 1 center, and 2 wing tanks. The fuel capacity is approximately 94,210 kilograms. Fuel management is automatic. A sensor mounted on the underside of the aft fuselage detects tail strikes. If a tail strike should occur, the flight crew is alerted on ICAS. The steerable main landing gear consists of 6 wheels per truck. Carbon brakes are installed to provide greater braking effectiveness while keeping weight to a minimum. The 777 passenger compartment can be configured to meet the individual needs of airlines. 366 passengers can be accommodated in a two-class configuration. In the typical two-class cabin configuration, seating for business class is 7 abreast and 9 across for economy. Lavatories are located throughout the cabin. They can be rearranged within these areas, known as flex zones, to suit changing route requirements. Similarly, the galleys are located here and can also be rearranged within these flex zones. Emergency equipment is located throughout the cabin. Emergency slides and rafts are installed at each passenger entry door. From the CMS touch-sensitive display, the cabin attendant can control cabin lighting, cabin temperature, passenger address, and other cabin systems. The pilot's seats are fully adjustable and electrically powered. As with other jet transports, control panels consist of the overhead, glare shield, forward panel, control stand, and aisle stand. The displays on the flight deck use the latest technology. Flat panel liquid crystal displays, or LCDs, display the basic flight instruments and navigation data. The primary flight display, or PFD, combines the basic flight instruments and annunciations into one display. The navigation display, or ND, displays route and navigation information. The center displays show engine indications, systems information, and crew alerting. The normal standby flight instruments are also displayed on LCDs. Two cursor control devices on the control stand allow each pilot to access some communication system functions, electronic checklist, and other information. The touch-sensitive pad of the cursor control device permits control of the cursor position on an active display. In the 777 airplane, a new system called Electronic Checklist, or ECL, allows the crew to have instant access to all normal and non-normal checklists. Here the crew has been alerted to a problem in the hydraulic system. With ECL, the necessary procedures are stored electronically and are available to the crew with the push of a button. The checklist system has the capability to sense switch position or system states. This lessens crew workload and provides feedback for the procedural actions. The radio communication system consists of the usual VHF and HF systems. In addition, a satellite communication system provides both voice and telephone communications. The VHF, HF, and satellite systems provide the capabilities to send and receive data link messages. An Airplane Information Management System, or AIMS, provides central computing for this highly computerized airplane. AIMS integrates 7 computing systems. The primary display computing system controls flight and airplane system information, which is presented on 6 main displays. Thrust Management Computing System operates the autothrottle system. A Data Communication Management System provides ACARS communications and controls flight deck printer output. Central Maintenance Computer and Aircraft Condition Monitoring Systems provide airplane system functional status to maintenance personnel for troubleshooting. The Flight Data Recorder System records mandatory and optional flight data for the most recent 25 hours of operation. And the Flight Management Computing System, or FMC, provides lateral and vertical navigation and also auto-tunes the navigation radios. Throughout the course, you will hear reference to the term 629 data bus. The 629 data bus is nothing more than a bus that allows transfer of computer data to and from the many computers and systems of the airplane.